Leaving Cert Higher Level 2014, Sample Paper 2, Question 5. This is a trigonometry question where you're needing to know and understand the concept of a sine wave. We have a sine of 2x drawn on a coordinate grid, and we're asked to first of all be able to sketch the curve for just basic sine x. You need to know that the sine x curve has a period of 2 pi, 360 degrees, and it has a range from -1 up to 1, which means that in terms of and also that your sine curve starts at the origin. So we have the point, the origin here. We have the end of the period at 2 pi, and we're going to have a curve that goes in between those, just one revolution. So we have a situation, and it goes up as high as 1, through halfway through the period, down as far as -1, and back up. So we have a point, graph, and the key thing is the key points are those on the curve. As long as you hit those points and give a reasonably smooth curve, you've fitted the criteria. And don't forget to make sure you label up your graph. Now I've used colour, so I'm able to reference it. If you didn't use colour, you'd have to draw very close to the graph the name of the graph. In this case, it's g of x is the function. For the second function that's been required to graph, which is 3 sine 2x, obviously you need to appreciate that this is just 3 lots of f of x. That's all that you're being asked to do, because fx is sine 2x, and you're asked to do 3 lots of fx. So this is just a transformation where you're stretching in the y direction the black graph that you've got on your coordinate grid. So if we just stretch each of those points out, we're talking about each point here being moved up multiple of 3. This point here, multiple of 3. This point here, multiple of 3 up. This point here, a multiple of 3 down. So we end up with a graph that's going to have the key points. So creating a curve that goes through those points. And that is your graph for h of x. I should point out with both these two graphs that you've drawn that you should continue the graph in both directions. So beyond that basic sort of section that we're concentrating on from 0 to 360, you need to carry on your graph in both directions. And for the second one, h of x, again the same idea. Again, to remind you, we need to clearly define which one is G and which one's H. So the worst case scenario, if you hadn't used colour and you're doing a key at the side, as long as you're able to label your graph at the side of the actual curve, which one is which, you should be able to get away with that one in terms of an exam. Part B is asking you to look at the point P on your graph. And what are the coordinates of this point P? Well, since it's on this line, y equals a half x. Sorry, y is a half. Sorry, not y. Y is a half. We have a situation where all the coordinates along here have the y coordinate of a half, including p. So we can straight away say that this point P is going to have the coordinates of something, comma, a half. And it's just a case of working out what that x value is. The two functions are equal to each other. F of x is equal to y is a half. So we have a situation where sine of 2x is equal to 0.5. Performing the inverse sine of a half, we end up with a situation where 2x is equal to pi over 6, that's 30 degrees, and pi over 6 in radians. But this is not the only value for 2x, as you should remember. There are usually more. It's an infinite number, but in terms of what we're looking for, depending upon what your range of values of x are, what your angles are, there'll be more. So in this instance, for sine is positive with 0.5. So in the first and second quadrants, we also have an angle of 150 degrees, which is 5 pi over 6, 5/6 of pi. And since the angle that was given, the sine function, is 2x, what we're actually going to do, we're going to do 2 revolutions. So we're going to go beyond 360 degrees by adding on 360 degrees, which is 12/6 of pi. We end up with 13 pi over 6, and adding on to the 5 pi over 6, adding on again another 12 pi over 6, we end up with 17 pi over 6. These are values for 2x, so then if we divide these all by 2, we end up with pi over 12, 5 pi over 12, 13 pi over 12, and lastly 17 pi over 12. There are more, but they're the only ones that we're interested in within this boundary of 0 up to 2 pi, because p is within that section. And more specifically, we can think about where exactly that value of the x-coordinate of p actually is. If we think about these 4 solutions we found so far, you can see that we have pi over 12, 5 pi over 12, 13 pi over 12, 17 pi over 12. And especially since we can see that this is 3 halves of pi, halfway between pi and 2 pi, so it's 1.5 pi. A value of 17 pi over 12, which is just a little bit less. 17 over 12 is a little bit less than 1.5. This seems like a reasonable answer. So in terms of the coordinate for p, we have a situation where p is 17 pi over 12, 0.5.